So you can do a surface analysis, edge analysis on this, and check if there are any. No edges, so it's completely closed, which is good. You don't want anything intersecting with itself. Yeah, it has to be a nice clean shell like this. I wonder if this might be a reasonable one to just 3D print even. Okay, so maybe we'll skip this one for now. What else do we have? Okay. I've got a feeling this is going to be a similar thing. You tried it? Okay. So it's I think it's something to do with the way that it's trying to find the intersection. So we could maybe try, say, contour.
X and Y.
Eh? What's that?
Paper divide. Okay, control X and Y. It dividing the vehicles.
Yeah. But the bucket doesn't really lend itself to this method either. Yeah. Does anyone that have something that does make sense to slice up? Please just upload it. Yeah, so the contour command sort of seems to work reasonably well in Rhino. But if we try that in our Grasshopper code, let's see what happens. Just create another mesh, reference it in. And we can do contour. Shape is the mesh. So just hover over and see contour start points. I might just define a point on the vertex. Oh, yeah. Contour normal direction is just straight up. It's 0, 0, 1, so X, Y, Z. And then the distance between the contours are 3 before. Cool. Okay. That works. It must have something to do with the way these planes are intersecting with the mesh. So if we try it with this method, How many models? Red length. Okay, so we've got a series of planes that we're going to use to insert the mesh now. It looks like that worked pretty well. Let's try it with this one. We should attempt to contour this first. Let's see what happens. Oh, I didn't like that. I think I still had it active. Yeah, my bad. I'll just Control E those, or right click disable. Let's do a manual contour of this one. So, base point, just pick a point down here. And the extents. It doesn't matter, that's just the direction. And then every, say, let's go 10 mil. Okay, that worked. Great. How cool is it when it does that, right? Just like a ripple. So all of those are the contours. Yeah. So I mean, potentially, if you had a small enough object, you could fabricate it using these contours. Like Larry suggested last week, I think. The contoured, plates. It could be a good way to make something. Yeah. So now let's try it in here. I'll make this 10 as well. And move these down here. I'll just lock that shape so I don't keep selecting it. Cool. Then I'll what I should do, I should share aliases with you. I will do that. That command that I just put in wouldn't work for you just yet, but I'll upload the aliases to Slack. So yeah, as you can see, the contour command worked nicely with this one. Cool. So yeah, so then we can just sort of say what sort of resolution we want to create there. And yeah, go through a similar process of creating a little bit of a structural element within this space. So what I'll do is I'll do things a little bit manually. So that which one?
This one. The 3 dot.
This one?
Divide
That
by
is divide by length, yep. I can turn the full name and yeah. Alright, so yeah, so we're using the mesh intersections. What we're using here, everything looks foreign to me because I always use icons. Yeah, mesh plane. How weird is that? Okay. Let's try this again. Okay, so there must be one of the curves must be open or something, so that it can't calculate the area. Yeah, okay. I'll have a look at that problem later. It's one of those like niggly little things that when you have when you're attempting to intersect with meshes of VROW geometry, sometimes the curves for some reason act on a different tolerance or something, and it breaks down. Okay, so yeah, so we can use a little bit more of a manual method. So if you're sort of entry-level Grasshopper, have a go at doing something like this, just setting up a method to divide a curve by length, create a bunch of planes, and split your mesh. And then what you can do is go back into Rhino and make a new layout. Just call it contours 0. Make it active, so you just click there to make it active, and right click on your mesh plane intersections and hit bake, and then bake it in onto that layer. So then you've got those curves like that. So I'll select those and just drag them out of the way there. Use zoom selection to zoom in on the object. It looks like we've got a tiny little contour there. We'll just get rid of that. Maybe that was the issue. Could have been. But yeah, so what you can do is do things in batches. So if you select all of these curves and you extrude the curve, and then say whatever your material thickness is, in my case 4 millimeters apparently. How tight was it?
It's 3 point something.
Yeah. Here, pass me the banana.
I have a question.
Yep.
So the object, when you import the object to Rhino,
Yeah.
should it be like like is there any restriction?
Yeah. So I mean, yeah. So as clean as possible. Do you have an example of a messy model? Okay. Okay. Well. Yeah. Yeah. When you're physically fabricating something, you want it perfectly clean. The UV mapping doesn't matter as much. But um, the main aspects of the model, it shouldn't have any self-intersecting meshes. So it shouldn't be like jabbing into itself. So in Mudbox, when you're texturing up things like crazy, you may end up with some intersecting meshes. Yeah, but there are some fixes around that. But if you have intersecting meshes, then it's really difficult to generate these sort of files. So make them clean. Yeah. So here 3.5. So then that extrudes all of them. That's pretty much what we want. Then I can select last to just select those. And my method for modeling in Rhino is I normally just move things out of the way of one another and make copies as I iterate through the design solution for how I'm going to fabricate this thing. I think I may not have moved these very strategically. So there we go. I'll just check that there. And while you're working on detailing things, I tend to hide everything else, which works quite well. So what we want to do next is create a vertical slice through this, so that we can create some sort of structural element. Excuse me. Okay, so we can do that by just drawing a curve, more or less any way you like, and make sure it's say below that object. When you go into top view, you can split this is one way to do it. It's probably not the best way, but let's do it this way. So that should split your mesh into half, like so. And then what you can do is use dupe border, and it should extract that shape around the edge there. Yeah, so I'll do that again on this shape so I know it's more or less in the right place. Dupe border. Okay. And I'll send that over to this one. Okay. And and then when I extrude this, I'll do the alias thing right now. So in Tools, Options, Aliases, I've uploaded all of these shortcuts, and I sort of add to them as I go. So if I need another shortcut, say, what's the other one? Yeah, so I can go new, say S2 for instance. You just sort of guess with what comes before it. I normally do the exclamation point and underscore. That basically just suppresses some of the pop-ups and that sort of thing, I think. I can't remember. Doesn't matter. And say if we want to scale 2D, for instance. That's just an example of a command. So scale 2D is a command, but we can create a shortcut for it, S2. Then we just go OK, and now I can go S2 and ask me which objects I want to scale. So whenever I'm doing, like, I've set up all my commands, so EC is extrude curve. If you typed in EC, just try this. EC, yeah, so it comes up with like echo or whatever, right? But with my aliases, I can use EC, extrude my curve, solid yes, both sides yes, material thickness. What do we go with? 3.5, I think it was. I think I went 3.5. But maybe 4 is better. We'll go with 4. Solid yes, both sides yes. 2. 4? Great. Alright, I reckon we'll do the extrude again. So this is why I don't delete anything, because I can just go back here, select all this. I think I went both ways. Why is that one broken now? That's weird. Okay, so that curve isn't joined properly. Okay, so I just selected all these these curves. I can use Control J to join everything. So now that should be fine. Cool. So select last and move it 1000. Alright. Cool. Okay, so now we've got to think a little bit about the logic of how we're going to actually slot these together. It seems to make sense to like maybe create a slot in that one that way, and then vice versa for this one. So the way I'll do that is usually through Grasshopper, but we'll do some manual stuff. Just because I'm conscious that the Grasshopper thing broke very easily at this stage. So if you can't find your snaps, there's an OSnap button down here that enables them, and I think that if it's not there already, it'll pop up if you hit that. I'm going to guess for this, on the smallest object, we'll just take the center-ish point, and I'm just drawing a box. Oh, so many snappings. Okay. Right. Hold on. So right click is repeat commands. I've been doing that a little bit. Okay. So just make sure the shape covers everything there. And then what I'm going to do is use array. X direction 1, Y direction 1, Z direction, however many contours we've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Z spacing. I'm going to go into the left view for this. What happened? We'll go into the front view. And pick a point there. Make sure what the heck? Oh, it's so weird. I have to, yeah. When you're stating a distance, apparently it doesn't want to snap to the ortho. So I'm just going to put a dummy curve in there for reference. So if we do array 1, 1, 1, 10, and then the distance. What? 1, 1, 10. Z spacing. Oh, that's just. Okay, so with the array command, either always do it in the top view, so then the XYZ actually matches with the global coordinate system. Otherwise, it changes to the viewport coordinate system. Apparently. Let's try it. Yep. Okay, so array. There we go. Alright. So everything aligns really nicely. Great. Whenever I'm creating cutting pieces, I always just create a new layer called void and change the color to something fancy. So then I know that all this stuff is just to cut out other objects. Okay, so before I cut all that, I'm going to copy this across, and then I'm going to cut it, because then I can go back to my original object with all the reference objects there, so I know exactly what I did, and then I can use my alias CB, sorry, not CB, BD, only difference. And then select all the objects that you want to cut down. So if I select that, that should have all the slices in there. And then the next step is really easy, because it's just a matter of cutting out all of these guys. Yeah. Sweet. Not so sweet. So where you, yeah, where you're not covering everything, you're getting some weird stuff happening at those intersections. So I'm going to go back here again. I'm just going to offset this one in. I think we'll have to do it in the left view. Let's hide that one. Hiding everything. Okay. Offset. We just inset it, say 5 mil or something. Maybe a bit. A little bit safer. And then we can extrude that one. Both sides, 2. Goes down the center. Let's get rid of that. Actually, no. Let's continue on the evolution of this thing. So rather than deleting anything, again, I'm just going to move this up. We'll just go further. Then I can take this one. Get rid of that. I've still got it there if I need it. And then copy all this across. Just get rid of that. Okay, and then we'll cut out this one with these cutters. We can delete those, and then select all these ones. Go wake up. Oh, how did I select those? Hopefully we'll get some nice clean pieces now. Nope. So we also need to cut out that little bit. Yeah, so we want to go the other way. So we go back here again. There we are. This is the beauty of not deleting anything. I'm just going to offset it like that. Extrude both ways, 2. Let's go again. Whoa. Okay. So, yeah. Alright, so now we'll cut that one. Let's get rid of those. select these ones. Use that as the cutter. Okay. Let's use select class. Copy these across, and then I can take the one that I created earlier here. And slot that one in. Sweet. Yeah. Okay, so you'll notice that you get a couple of lines here. That's fine. That's just because the slotted geometry, when it cut it out, it created a couple of what you call ISO lines on the surface. It doesn't mean there's any sort of error or anything. All you have to do is clean it up. So you just merge all faces, and then you get a nice clean object like that. What is it? Alright. And then, yeah, so you can merge your faces with all of those objects. The central one should be pretty clean, because we just sliced boxes out of it. But it's just where those surfaces overlap that you get a little bit of messiness. Yeah, so there we go. That's our object. That's kind of what we want to make. Cool. So now the next step is to extract all of the outline curves that you want to cut out. So the best way to do that is to use extract surface and just make sure that copy is on. But before you do that, create a new layer. Let's use like laser prep. It's like a temporary layer just so that you can recognize what you've extracted and what you haven't. Make it active. And then extract surf. Copy yes. And then just select these surfaces that you're after. Oh, it didn't change the layer. And change them to the layer that you had. And then you're left with just the surfaces that you want to lay out. So everything, yeah, everything looks clean. That's good. If we tried to extract these surfaces before we merged all the faces, then we would get the wrong surfaces. Like, maybe I'll show you that. Yeah, let's just grab that one out. So while it has these ISO lines there, if I try and extract the surface, it would just select that one. I would have to select it multiple times to get everything that I'm after. And then, even then, they're not going to be joined, so you have to join them, and then you have to merge all faces anyway, and then you end up with the clean. So it's better to do that first. Okay. We'll just hide everything else. This is all we're after at the moment. Is there any questions so far? No? Yes?
Those lines on a book, can you just mark together?
No, because they're just identifying the edge of the surface. Because these objects are, so it says polysurface, and so they're made up of a series of surfaces. So with this one, if you explode that out, that's a surface, that's a surface, that's a surface. Yeah. So it's just defining the edges. Yeah. Cool. Yeah. Cool. So, alright, now if you've stuck to the global coordinates of slicing, so it's all orthogonal, it's 90 degrees everywhere sort of thing, then it's reasonably easy to flatten this stuff out. But if it's some sort of weird shape, then you need to flatten it out. The easiest way to do that is using the unroll command. So unroll surface, and say explode no. It doesn't really matter in this case, but usually you go with explode no. Let me confirm that. And then all the way over here, it's laid out flat. Yeah, that's a way that you can get it on the ground plane really quickly, as opposed to sort of manipulating it manually. You can go like 90 degrees, move it out with the gumball, and then go like move to 0, and then it's there. Pretty much the same thing, but Unreal Surf just does it straight away. So let's try and do it on these. I think it won't like it. Let's see. So that's the other thing. Like you have to select surfaces individually, which is a bit of a pain. I might do a quick little Grasshopper thing for this, so that we can just do a little tiny little script again, just so we don't, because when you guys look at like that, who's like, oh man, that's crazy. That's normally what people think when they see the Grasshopper code for the first time. But then if you just look at it in sections and hover over the inputs and the outputs, you begin to understand what this bit is doing. And then you move on to the next bit and the next bit. You just work through it. It's a diagram. It's just got layers of complexity that you can reveal. And yeah. So you know, this is a segment that you could understand quite readily. It's just similar to Rhino commands that you've used manually. So with this one, I've got a surface here. I want to reference in all of these surfaces. And the great thing with surfaces in Grasshopper, they act kind of like planes as well. So if you want to orient these to the geometry, the source, which will be just the surfaces again, and then it defaults to a plane, and then the target is XY. If you middle right mouse click on the mouse wheel, then you can zoom into what you just created. Everything's flattened out. Boom. One little thing. Yeah. So then, let's say flatten geometry. So if you have that layer active that you want to bake onto, another way to do this is insert. Otherwise, you can just right click bake, and it does the same thing. Yeah. Cool. So if I close that and select select objects, then we've got all these things that we lay out in some sort of manner. They're kind of like random objects, though, right? We need some sort of labeling system, maybe. And potentially, like on the, I didn't label my banana very well, so I didn't know where each one goes. I just do it visually, or I did etch little numbers into each of the these pieces, so I know the order at least. Blow my nose. Okay. Sorry. Okay. Alright. Yeah, so we don't really know which is which. So we go back into Grasshopper and let's see if we can create something that helps us to recognize what things are. So with each of these flattened out pieces of geometry, so trimmed surfaces, we're going to put it into the area command, and that gives us a center point coming out of the centroid. Then what we can do is, just for a visual, we can just throw in a points list, and then we automatically get numbers. They're just at a really small scale. So if I double left click and type in a number, then we can hopefully see something. Okay, you can kind of see the numbers. Can we bake this in? Yes, we can. That's cool. But yeah, we still have this issue of trying to figure out which one's which, because they're just all overlapping. Something that I built into this code here is that it like shifts everything out, so it lays it all out perfectly-ish like that. We can do a similar method, but it starts to introduce you into lists and data structures a little bit, not much, but just a little introduction to it. So let's give it a shot. So from our oriented objects, we want to move all of them out at increasing amounts, so that it sort of goes through, like a deck of cards, or fan them out. So what I'm going to do is do something based on how many objects there are. But if we have like a different amount, this length is what I'm after. Then it can update automatically. So it's got 11 objects with this series thing. We've got start at 0, step 1, count 11, and then we get 0 to 10. So there's 11 values. They go 0, 0, 1, 2, all the way up to 10. And then we want to multiply this by some value. We'll use a slider, maybe 200. Okay, so then we get 0 to 2000. We can also just throw that into the step, but I also want to use these numbers for something else. So I'm going to do it this way. And we use an x vector, throw it into the factor so that we get x vectors. Everyone know what a vector is? Yeah. It's something with amplitude and direction. It's like Despicable Me villain. Vector. So track that into motion and they all spread out all over the place. And we can increase this value and they're like, more or less not overlapping, so we can make sense of it. This is like really hacky way of doing it. You can have a look in this. It's much more refined, but there's just more going on. So I'm going to try and do it with like minimal components here. Okay, so then our transform geometry we can just plug into the area component, so then we get our numbers again. Audio. Alright, so now that I know that it's kind of working, I just hide everything else. And then that one and that one is what I want to bake. And then you just right click here and bake those objects. And you'll notice that that type of point numbering system creates these sort of like text dot things. You can't laser cut them. No, can't explode them or anything. They're just useful for virtual numbering. So let's do a different version. You need to define a plane and use a text tag. So we want to use the text tag 3D. Location that expects a plane. So those ones. And then the text that you want to display. That's what I was referring to before about the series. So you've got 0.0, 1.0. We just want 0, 1, 2. So we use an integer. So then we get just 0, 1 through 10. And throw that into the text. And then you can define the exact size that you need it. So when you're laser cutting the text height that I went with, I think is like 2.5 or something. That's like the tiniest you want to go. I'll probably give it a 3. Be really small on this one, but you just have to be able to read it. So I'll make sense. Okay, so that one and that one. Right click, like. Cool. Alright, so where's the 0? There it is. Cool. Alright, so now next step is these text items are text, then or they're a surface, sorry. What are they? You can sell text. There we go. Okay. So it's described as text. So it's like a weird like hatch or something. It's not really a surface or anything. So what you need to do is explode it, and that changes them to curves. So then we're at the point where we can create an etch layer. I already have one. I'll create another one. Create a cut layer as well. Oops. And I think I'll just use the same guide layer as before. So these text curves go on the etch layer. I'll just change the color of that one. And then all of these surfaces that you've got there, if you select all of those, you want to dupe border, and then that gives you all the outlines, and then change those outlines to the cut layer. I'll just give them a blue. And then you've got all of the outlines for all the surfaces. They're all on the ground plane. They're just spread out. So let's now we'll hide the surfaces. So we're just left with the curves there. Go on the top view. Let's see what else we have here. It's looking a bit messy. Just move these down right out of the way. And on our guide layer, create something. Ideally, you really should put your geometry really close to the origin of the world plane, because when you export it, then it will export nicely. It won't be like way off the Adobe Illustrator page. So the laser cutting beds are more or less 800 by 500. I'll just lock that one in. Whoa, that was unintentional. Alright, I'm going to move all this stuff. And hide it. Alright, now these guys, yes, obviously these curves won't move with these curves yet, so what we want to do is just group them up. And we'll just repeat the command by right clicking select them together, group, 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 group. Okay, and now we can freely just move them around, and by just grouping them, the labels stay with the object, but they don't change layer. So then you can still manipulate each of them. And the reason why we have these on separate layers is because we want to set the laser cutter to a different power setting, so that we just etch the object as opposed to cutting it down. Yeah. So then we just go through the process of nesting these objects. It's a little bit more difficult when it's a really organic shape, but that's what we're after, right? Okay. So that's one sheet. So obviously this boundary should be the size of your sheet of MDF or whatever it is that you're using. Yeah, I tend to lock these guides so that I don't move them as well. I can just easily place all of these objects in. And there's no real rule to like how far apart each of these objects need to be. If they're like orthogonal objects, sometimes I'll even use the same line if they butt up against each other. It doesn't matter for this stuff. When you're doing the final thing and you want to make sure that you get everything right and you're using some really expensive material, then you space things accordingly. But we'll get there for sure. But right now when we're prototyping, just rule of thumb, like leave like maybe like 2 mil, 1.5, 2 mil between each object. Make sure you don't go too close to the edges as well. Probably a little bit close there, because the way that the material is aligned on the laser cutter, you might misorientate it or whatever. It can't tell. No, that's it. Okay, so don't spend too much time arranging things, but spend enough time that you're not feeling like you're wasting material. Okay, cool. So this is all set to go. Unlock that. Delete that one, I don't need it. And then I guess I should probably like save this. The autosave has been going, but what do you want to call this one? Have you got a name for your blob? Your face? Is it like face wind?
Okay. You design it.
Face wind. Face wind. Okay. And then I'll export this, so I can right click on this one under the standard tab. And where are we going? Wow. Okay. Make sure you have a folder, whatever the number is that you choose for the folder, and then say laser, laser files, or just laser, that's fine. And choose Adobe Illustrator, choose a name for it, face wind, 0, yep, because you may iterate the laser files for this. make sure you're on preserve model scale and that your scales match. So 100 millimeters equals 1000 millimeters equals 1000 millimeters. Make sure this is the same as that one. Should be an RGB, but doesn't really matter. Yeah. Okay, and then let's have a look at what we just created. Cool. So what I normally do is just show rulers, and then you can right click on the ruler and choose millimeters. So then you've got some sort of reference, and then just check with that page. It's at 0, 0. Looks good. What we can do is make this one a little bit bigger. I suppose it's going to move now. Yeah. Don't move your documents around like that because you'll probably lose your numbers. Yeah, so the thing is when you bring it in from Rhino, you lose your groupings, but you still get your layers. Yeah, so if you still need to arrange things a little bit, you notice that you made a mistake and things are overlapping or whatever, then you have to select both of them and move them around. If you group them, then they get put on the same layer. So then, obviously, when you go to cut things, you're going to cut your number out, which is not necessarily what you want. But of course, you can always fix that with the selection tool. So you can. That's the reason why I made them different colors, so that you can easily just select the same appearance and then fix up your layering if you made a mistake. Yeah. So now, next step, if you're happy with all of your layouts, you should align all of your objects to the page. I think we need to hide all this other stuff. Otherwise it's going to freak out. So what we might be good practice is to do this within Rhino. Is just label each of your pellets, but do whatever's quickest, because you can easily waste a lot of time being too organized. Sometimes you got to keep it messy. It's quicker. Label. Everyone know like that. So if you hold down Alt, you can toggle between everything else locked, except for that. What am I doing? This one. Move that. Get that like that. Go. Okay, the guides don't matter because we'll just hide those. And at this point, I'll save it. You can save it as the converted one or just over the top. Doesn't matter. Okay. So last thing is to select everything and change your line weights to 0.001 millimeters. But you'll notice if it's coming up as points, it'll be 0.003. It's the same thing. Within CS6 on my laptop, you can still see the curves. Downstairs, for whatever reason, you can't see the curves. It's a real pain, but yeah. So that's the line weight, 0.003 points or 0.001 millimeters. And then you want to change the stroke. Oh, that's weird. What else is it? Is it just because they're different? That's weird. Isn't normally like that.
You logged earlier.
Huh?
You logged earlier.
No. Like that works if I do that. That's really weird. I'll just do it that way. I just want to make them black. I don't know why that's so difficult. So I have to do this again. Cool. Now that's ready. Laser cut. Face wind.
Do you need the number 5? That one overlap with the...
Yeah, it's pretty close. Yeah, so cool. Alright. So save that. And then if you're using the laser cutters downstairs, then you can log on to those and just use your like my desktop or whatever to transfer the file to those computers. Yeah, I'll just put them online somewhere. USB stick. Is that old school now? The USB stick? I think it is, right? Yeah. Yeah. Mine's tiny. It's literally like yeah. Alright. Cool. Yeah. Mine's smaller than that. Okay, so is there any other questions?
How do we set different strengths, like the intensity of text and model?
What do you mean? Sorry?
How do we change the settings in order to change the intensity of text, like for the etching and cutting?
The power settings and that sort of thing. Okay. So that happens at the laser cutters. Yeah.
In the industry, they used to just set everything with the same setting.
Yeah. 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 It depends on the laser cutter. Some laser cutters you can choose different colors that mean different settings for the laser cut. We don't set up the laser cutters like that, so we just send separate files. So when you get down to the laser cutter, you'll hide the cut layer and go into File, Print, and then set the setting for etching. Yep, etching 3mm, 4mm MDF, and then do the opposite for the cut. So set the cut depth, the cut strength, Yeah. And then it's done. And put it together. If you have the material thickness correct.
But what if I want like 1 mils etch in 3 millimeters, like both?
Sorry.
So if there is a number 1, 2, 3, 4, 5, and I want each of them to be etched on a different size, like one is etched 3 millimeter, two is etched 2 millimeter.
Okay.
So that
Yeah.
I set the lines for.
Yeah, you can't really set the depths really specifically like that, but you can do like a variation in depth with etching. You can etch an entire black and white image that has grayscale to it, and it will etch it at different, at different depths. But you can't necessarily say etch at 2 millimeters depth, because it's very dependent on the material and the strength of the laser. It's a very non-linear system that you have to, so a lot of trial and error to be able to do it accurately. Yeah. Cool. Okay. Yeah. So now I think just check in whether we can head over. Or if we pick up things. Just give me a couple of minutes. I'm just going to have a chat to Marcus. Cool. I'll upload that new Grasshopper sketch as well, and the Rhino file. Hi, how are you? Good. Not bad. I'm like struggling with a bit of a cough and that something, but you know. But yeah, I wanted to check with you if it's okay to bring about 20 students over to do a bit of a demonstration just next door in the lab. We've got a wind tunnel that's set up, I think, and some dry ice. So yeah, we'll probably just be a little bit noisy for like 45 minutes to an hour, just before lunch. Yeah, cool. Alright, we'll be as quiet as possible. Alright, cool man. Thanks. Okay, bye. Cool.
Did you want to let that ride?